welcome everyone. Thanks for coming. Today I'm going to give sort of a little bit of a history of sort of where the project came from, how it got to where we are today, and then give you a little bit of a glimpse of what it is we're currently working on and where we see the project moving into the future. So I'm going to start by showing you a picture of how we usually talk about Ceph. This is sort of a block diagram of how the system is built, and this is sort of traditionally how we present the system. So at a very high level, you have what we call the RADOS storage cluster, which is a scale-out object platform where you have lots of different commodity storage nodes that you can deploy lots of different stuff on top of. And that gives you a generic sort of storage platform, essentially, that you can build lots of different services on top of. And we built the Ceph object gateway that gives you S3 and Swift compatible RESTful object storage. We built a block device that gives you virtual disk. That's been very popular sort of in cloud architectures and deployments. And then we have the Ceph distributed file system, where we built sort of a full-blown distributed POSIX file system, again, on top of this object store. So the idea is that you have a unified storage platform, and you can use all these different interfaces to sort of access the same set of hardware that's presenting all these disks in a highly reliable, highly available sort of way. I bring this up now because I think the interesting thing about it is this is not at all what we started with when we set out to build Ceph. In fact, we started in sort of the supercomputing space trying to build a distributed file system. And over time, we sort of evolved into this unified storage platform that we have today. So today I'm going to give you a little bit of a, let's sort of cut up on the bottom here, a little bit of a picture, a little bit of a history in terms of where we got, how we got to where we are today. So this is a plot of contributors per month over the last 9.5 years, 10 years, I think, in like 2 weeks. Which is kind of exciting, which I think we sort of logically divide into a couple of different phases. So there's this first phase where Ceph was sort of coming out of the research group, and it was a bunch of academics trying to build this highly scalable architecture that was sort of deemed the research phase. There was sort of a middle phase where we were incubated, sort of initially building the system after it was open sourced inside of DreamHost, which is a company that I worked with previously. And then the last 2 years is sort of the InkTank phase, where we sort of launched a full-blown support company behind Ceph when we saw things sort of really take off up and to the right. And started doing things like Ceph Days and talking to banks and so forth. So I'll start with sort of the research background. So it all began at University of California, Santa Cruz, in the form of a research grant from the Department of Energy, Lawrence Livermore, Los Alamos, and Sandia. And the idea here was to build a highly scalable file system for high-performance computing. So it was all about scalability, reliability, and performance, writing terabytes of data per second to these huge supercomputers, basically. When I became involved in the project, my focus was really on the scalable metadata management. So how do you keep track of a file system namespace with files and directories and inodes and permissions and all that stuff that will scale to, 250,000 cores dumping files into the same directory. The first line of code was written during a summer internship in 2004 while I was at Lawrence Livermore, which was sort of a very surreal experience. I was in a high-security national lab environment with a little radiometer on my badge in this old 1940s era building, checking in my code over SSH CVS to University of Santa Cruz. It was sort of ironic. And the nice thing is I was told essentially that I could work on whatever I wanted, within, because they liked what I was working. They could work on what I wanted, which they happened to like, as long as it was open source. So I was like, great, that's exactly what I want to do anyway. So over the next couple of years, after that sort of initial genesis, we sort of built the rest of the Ceph architecture. So it started with, how do you deal with the scalable management layer? But we built the RADOS component, which is a distributed object layer that sort of sits underneath it and manages all the raw disks. We built a system called EBOS that was a custom object-based file system that manages all the data on a single disk and stores objects on it. It was sort of a simplified local file system. We put together the crush algorithm, which is essentially a way to algorithmically distribute data across lots and lots of storage nodes in a way that takes fault tolerance and failure domains and all that stuff into consideration. It's very flexible. And then sort of this Paxos management framework that sort of orchestrates the entire cluster. So over the next couple of years, we sort of assembled all these sort of disparate ideas that have been floating around within the research community in our group in particular, and built it into like a single actual working prototype that you could actually run and read and write data from, which is kind of exciting. So over this period, there was always an emphasis on building consistent and reliable storage. we're building, a POSIX file system that we want to have sort of strong coherency and strict semantics for, so you can run legacy applications on top of it. We wanted to push the limits of scalability by pushing all the intelligence, or as much intelligence as possible, to sort of the individual components in the system, so that you could get sort of the massively distributed, very scalable architecture. And at the end of the day, we ended up with a very different architecture than sort of traditional, SAN-based file systems and so forth. But it was very compelling, which is kind of exciting. We also named the system Ceph. So this came from one of the research professors that was involved in the project, Carlos Malton. So Ceph is short for a cephalopod, which is a squid or an octopus or something like that. So that was kind of exciting, that a cute beady-eyed logo. And as I sort of finished my sort of course in my graduate work, I observed what seemed to me sort of to be an industry black hole. So you had a storage industry that was dominated by lots of large storage vendors, the NetApps, the data domains, and EMCs of the world, that were selling proprietary solutions that ultimately didn't scale all that well. They would scale out to 8 nodes, 16 nodes, maybe 32, something like that. And we were trying to build something that would scale to hundreds or thousands of machines. There were very few open source alternatives, particularly at this point in time. They either had very limited scale in terms of the number of nodes that they could grow to, or they had sort of a limited community or sort of a antiquated architecture. And sort of by and large, they didn't have any of the sort of basic enterprise features that you would need to deploy these sorts of systems as a real business. So you didn't have things like snapshots or quotas or that sort of thing that real businesses really need. And the other thing that I observed is that all of my peers within these research programs would build very interesting systems as part of their dissertations that were really cool, and they would get them to work just enough to build all the plots to write their papers and do the graphs and everything. And then as soon as they graduated, they would get hired by the NetApps and the EMCs of the world, and their project would just sort of die on the vine. So there would be a paper published, but nothing would really come of it, and the system would never actually live on in the form of software. And I went through this process of interviewing and doing presentations at a bunch of these organizations, and I realized finally that they weren't actually interested in Ceph. They were interested in hiring me to have me work on their proprietary system, which ultimately wasn't terribly interesting. So I sort of opted for a different path. I had the luxury of not needing a salary that was to pay the rent at the time. And so my goal was to change the storage world with open source. Do to the storage industry what Linux did to Solaris and IRIX and Ultrix and all these sort of proprietary Unixes back in the day. What could go wrong, right? So there are a number of sort of things that you had to sort of do in order to make that happen, obviously. So we had to open source the software, we had to choose a license. We opted for LGPL, which basically means that it's a copyleft license. You have to share changes to Ceph, but it's flexible enough that you can link it into sort of other parts of the stack with proprietary software. So you can build proprietary stuff on top or link it underneath. But Ceph itself, sort of the storage platform, would remain open source, which seemed like a good balance at the time. We wanted to sort of avoid a lot of the unfriendly practices that I saw in sort of other open source projects. So things like dual licensing, where you sort of try to build up the community, but then as soon as people try to use the client, they can't link into their other applications, and you sort of force them to buy a commercial license, that sort of thing. We wanted to avoid that. And on the flip side, we also saw lots of projects that were doing things like copyright assignment and CLAs that were sort of unfriendly for developers who made it a very high barrier of entry to participate in the project. So we wanted to try to do everything right from the community perspective early on. And then you have to pick a platform. We put this up on sourceforge.net, if anybody remembers the days before GitHub. And so we open source the code, expected the patches to start rolling in and things to take off. And it didn't quite work out that way. It turns out that it's a long slog, I think, to build sort of a robust open source platform. So the next phase was really about incubation of the project. So after I graduated, I went back to work for DreamHost, which is a company I'd helped found prior to doing grad school out of college. It's a web hosting company based in LA. So I moved back to LA, continued hacking just on Ceph. I had the luxury of not really worrying about anything like deliveries or customers or anything like that. So we hired a few developers to start building Ceph into the next generation storage platform that we thought it should be. And we did a lot of things. So because we had sort of no deliverables, our customers, I guess, to answer for, or QA tests to pass or anything like that, we had a very ambitious feature set. So it was really about building all the things into the system and into the architecture that we thought were necessary to make something that was truly transformative, that could really take on sort of the proprietary vendors. So one of the first things that we tackled was building a native Linux kernel client so that you could mount the file system natively from the kernel. So up until that point, we were using Fuse, which was sort of a stopgap solution. Didn't perform very well at the time. We did things like per directory snapshots. So anywhere in the file system, you can create a snapshot of any subdirectory, which is sort of the logical extension of having snapshots in enterprise systems where you had sort of volume granularity and whatever. We tried to be very flexible and do something new and exciting. Things like recursive accounting, which lets you look at any directory and see how much data is stored within that part of the hierarchy without having to do a DU, which is something that no other systems had at the time. It's kind of cool. I think still, actually. We built this object class mechanism in, so within the object storage layer, you could sort of inject your own code into the system as an administrator, assuming you had the permissions to do so. And you could sort of run methods on object classes that are stored in the storage node. So you can push computation all the way down to the storage layer, build sort of a more flexible storage compute architecture. RADOS was sort of a generic library that let you access that low-level object storage and build your own applications on top. So we're sort of moving outside of the realm of just purely a distributed file system, but into a sort of object-based storage platform. RADOS Gateway was a component that we built in 2009 that exported that low-level object API using S3 protocol. So S3 was big at the time. And later we added Swift support as well. So you could sort of, as a competitor to Amazon or somebody who just wanted to leave Amazon and run your apps in your own data center, you could run it on a pure open source storage platform in your own data center. We built in strong authentication based on sort of the Kerberos design, so you could actually run in a slightly untrusted environment. And RBD, which is sort of one of the biggest things actually in sort of recent years, is building a virtual disk that's sort of built on top of this object storage platform. So give you similar functionality to what you get out of a SAN. The biggest thing really that we built was the kernel client, though. This was sort of the thing that really sort of brought the project to the next level, I think, at least in our mind. So up until this point, we were using Fuse to access the file system, which at the time was not very fast. There have been a lot of improvements in the Fuse stuff in recent years, so it's not as bad as it used to be. But it was clear at the time that we sort of needed to, in order for people to take us seriously, we needed to build sort of a native client to bring things to the next level. So I started attending a lot of the kernel development events. There's this Linux storage and file systems workshop that I started going to in 2007 and presenting my big lofty research ideas to these kernel hackers who, I don't know what they thought of me. It must have been sort of interesting. But I got very encouraging words from some ex-Lustre developers that sort of bolstered my spirits, I suppose. But really started getting to know these people as peers and figuring out how to sort of plug into that community. Yeah, thanks. So that's when I met Rick. It's like 7 years ago now. So eventually had this 20,000 line patch set that implemented a client that actually worked and started spamming the file system developer list. Initial attempts to get this merged were rejected by Linus. He was like, who's going to use this and who wants it and whatever. There's not sufficient evidence really for user demand, but several people have been following the project and really wanted to run it. I think it was a couple of people at the labs followed up on those emails and said, actually, this is a big deal and we really want to see this get into the kernel. And after a couple cycles, finally he sort of relented. I think Andrew Morton probably was bored on a Sunday night and had a glass of wine or something, and he actually started reviewing a bunch of the code and basically sort of gave his stamp of approval. So finally, in 2.6.34, the kernel client was merged, and it was a big deal, and we celebrated. But I think sort of over this process, we also realized that Ceph was really needed, in order to be successful, it needed to exist as part of a much larger ecosystem. So it didn't have to be sort of a monolithic platform that solved all problems. That's part of the stack. So originally, we'd written our own file system to manage local disk to store objects. And at some point, we realized that in order to sort of make that robust, we needed to add things like checksumming and improve the memory management for the B-tree code and all this really annoying stuff that every single file system in the universe pretty much has to do. And we realized that Btrfs, which was a new file system at the time, was really doing all of those same things. It really had a very similar design to what we had done, and that we could just sort of use that and not reinvent the wheel again and have a separate community that's really focused on just making that sort of component of the system work well and be totally robust. So at that point, we sort of said, okay, we're going to drop this sort of custom thing and leverage existing Linux kernel file systems and make sure that we work well on top of those. So we did contributed some early functionality to Btrfs, like the ability to clone files, which is something that Ceph needed to do its copy and write snapshot stuff, and async snapshots to improve the performance of commits and so forth. So, and also over this period, we made sure that we also worked on top of XFS and X4 and so forth. But Btrfs was really the future, right? We sort of saw that at the end of the day, we wanted this pervasive checksumming and so forth throughout the stack. So, and we also saw that the Ceph community was really starting to take off. So we started hanging out on IRC, on sort of the public channels. We had a mailing list on the kernel.org email server, which was kind of exciting. We found basically that we had lots of interested users, lots of people who saw Ceph and were like, this is going to solve all my problems for my service provider organization and so forth. We had a few developers who started sort of hacking around the edges and getting involved. And we had lots and lots of fans who were like, I can't wait for this to be production ready so I can start to deploy it. But the reality was that the system was just too unstable in these early days for real deployments, right? We were about hacking together sort of a research project that did all these great things, but not so much around the sort of process and testing and so forth. So we were really focused on building the right architecture and getting the right technical solutions to the problems, but we knew nothing about how to ship something that you could run in production and support over time. So a couple things sort of happened to change things. So one was that DreamHost decided in, I guess, 2011, 2010, that they wanted to build an S3 compatible object storage service that was going to be based on Ceph. And so that sort of focused our efforts and made us realize that we needed to make it, production ready, I guess. So there was a new focus on stability. We focused on specifically on the core RADOS object layer that underpins everything on the block device because it was simple. And then the RADOS gateway, obviously, because it presents that S3 and Swift compatible API. It meant we sort of neglected the file system, which was a very painful decision for us, but it was also the most complicated piece. And sort of couldn't do everything all at once with the limited resources. We had to pay back a lot of technical debt. We started investing a lot of time in building testing automation. It turns out that there are no good systems, or certainly not at the time, no good systems out there for testing, automating the tests of distributed systems. So we ended up having to build our own framework. We started doing crazy things like code review, QA and stuff like that. And we worked to expand the engineering team. So when we first came into DreamHost, it was like 2 or 3 of us. By sort of the late 2011, I think there were like 9 or 10 engineers. So it was not a huge team, but we actually had multiple people doing reviews, sort of playing like we were in the real world, which was kind of fun. But the reality was really that we also found that we had growing incoming commercial interest. We started talking to the likes of the people who are here today who were very interested in Ceph and wanted to deploy it, but they had no idea how to talk to DreamHost, which is like a consumer web hosting company. It didn't really make any sense, and because really we had no ability to support commercial deployments. It just didn't make any sense. And there's this sort of clear realization that the project, in order to be successful, needed a commercial company that was going to back it and support it and pull it into production. So both to fund the engineering effort and to do all the testing and do the ongoing support. And so in 2012, we orchestrated a spin out of DreamHost to found InkTank, an entirely new company startup. So that's sort of the last phase of the evolution to get to where we are today. So we were going to build an open source company, right? And we wanted to, from the outset, we wanted to figure out how do we do this right? How do we make sure this is going to be a successful endeavor? Because as I think most of you know, that it's very easy to do it wrong. And there are lots of pitfalls along the way. Startups fail frequently just in general, but I think getting the open source business model right and sort of getting that right set of ingredients is going to be very challenging. So we went, how do we build a strong open source company? How do we make sure that the company is strong? How do we build a strong open source community around the project so that we can sort of leverage the overall efforts of the community and make sure that Ceph is successful? What are the models that we can look at? So there's REDHAT and SUSE and Canonical, which have sort of one way to do it. There's the Cloudera model, which sort of builds all their stuff on top and keeps that proprietary. There's MySQL dual licensing thing. There are a lot of different ways that we can approach this and sort of figuring out what the right combination was. That's a challenge. So we had some initial funding from DreamHost as part of the spin-out. Mark Shuttleworth, the Canonical founder, was a very early and vocal supporter, which was great, sort of getting us kick-started. So we had a couple of goals, right? So we needed to have a stable Ceph release to do these initial early deployments. We needed to lay the foundation for the community to make sure we had widespread adoption. So it was a lot of things like making sure we could support all the different distro platforms for everything with Ubuntu, SUSE, and Red Hat. You had to write documentation so people could actually install the thing, build and test infrastructure, that sort of thing. And then on the business side, we had to build out the sales and support organization. and hire more engineers to get that to work. There's this early decision to engage a professional industry for branding. Brian Bogensberger, the CEO of the company, as we started out, started throwing around terms like brand core and design system that I'd never heard before and was highly skeptical of. And we went through this whole process with the company that is designed to do this thing, which in retrospect actually turned out to be very interesting, but I was very skeptical as it was happening. So there was a very early decision to make sure that we separated the branding for the company from the project. So you see lots of open source projects and companies where the company and name and the project are the same. And you get this sort of blurring of the lines between what's the .org and what's the .com and so forth. We wanted to make sure that it was very separate, so that Ceph, the project, would be sort of independently successful and robust as a community, and the company would sort of capitalize on that, on the increased community traction and so forth. So we wanted to work very hard to establish a healthy relationship with the user and developer community that built up around Ceph. And we had the aspirational messaging. It was going to be the future of storage, right? We're gonna transform the world. We got all these slick PowerPoint templates that were really broken when you started using them on OpenOffice, and all this fancy stuff. They made some cool t-shirt designs, so it's kind of exciting. And the last 2 years have been sort of a wild ride up and to the right? So we started getting all these production deployments as we sort of had our first versions of Ceph. It's been sort of steadily growing. I can't count how many people are running Ceph anymore. The fact that it's open source means that lots of people are running it and they don't even have problems and we don't even know about it and we don't hear about them on the mailing list, which is kind of exciting. I can't even keep track of the customers anymore, which is kind of exciting. And we have a huge partner list. Everybody sees that this is sort of a strategic way to change the face of the storage industry and want to sort of figure out how their business model can sort of leverage that. So everyone from hardware vendors to software vendors to distros to all the rest. So that was all very exciting. We got lots of good press over the last couple of years, as people have probably noticed. And then this crazy thing happened where there was this totally independent industry thing that happened called OpenStack. This cloud thing happened that we sort of weren't really paying attention to. We were really about building a storage system for supercomputers, and from my perspective, coming from a service provider, it was all about just building a scalable system in the data center. And suddenly you had this huge movement where everybody was like, you need to build scale-out architectures for everything, run all your apps on top. And it turns out that the Ceph distributed storage platform was sort of a perfect match with the same goals and sort of requirements and so forth as OpenStack. So we sort of got to ride on some of the coattails of all that marketing money that was sort of shoveled into the furnace, and it's been big. So OpenStack was big, definitely. Obviously increased focus on quality. We had to do a lot more testing. We had to support Ceph across lots of different platforms, even ones that we didn't run. We came out of sort of a Debian company, and we had to learn how to use RPM build, stuff like that. We had to focus on things like upgrades. When you're actually deploying Ceph in the real world, you have a production deployment that's highly available, needs to be up 24/7, and you need to upgrade to the new version, and you need to do that in a way that doesn't require you to take down the system. So we had to do all the investments in all the feature bits and encoding and so forth over the wire so that you could actually upgrade a live system without interrupting any of the workflows. So we did a lot of that work during this period, which has paid off. And so forth. And we saw the developer community start to take off. So we started to have significant external contributors outside of the sort of DreamHost InkTank engineering team. We had first-class contributions of features. So the new Erasure coding functionality that came in the Firefly release that just came out a couple months ago was initiated by a developer at CloudWatt and sort of shepherded through the process, which is kind of exciting. InkTank was doing its agile Scrum thing where we have daily stand-up and so forth. We started to have external contributors from the community participating in all those meetings. So we try to sort of integrate the larger development community in that process. We have this big test lab that we put in one of DreamHost data centers, and we started giving external contributors access to that test lab so they can run their own tests and they can go diagnose failures using the same tools that we're doing. Common tool set, we're using IRC, email, all that good stuff, working with the distros. So we're really trying to make sure that Ceph is sort of doing all the right things to build the community independent of the business that's trying to build a product out of the whole thing. And one of the big pieces that came out of this was the Ceph Developer Summit, which Patrick plugged earlier. So this is really a community process for building the project roadmap for the next 3 months is sort of the cycle that we're doing. So it's 100% online. We use Google Hangouts. You don't have to fly anywhere or do anything. So it's very low barrier to entry. I think that the most challenging thing is that if you're in China, you have to use some annoying proxy to get on Google Hangouts. So those people tend to be sort of lagging and reliable, but all online. So make it very easy, and it's all on YouTube and so forth. So the first one of these was in spring of 2013. The fifth is going to be in a couple weeks. So we're getting kind of good at it now, and they're great feedback, growing participation. So far, it's proved to be a very good way to sort of rally the community. And it's also been an important way to take all the developers that InkTank has hired over that time and make sure that they're doing all their development in the open as well. So pushing all the discussion that normally would happen in the hallway onto the email list, using all the online tools and so forth. And as that engineering team grows and we sort of hire more developers, early on sort of forcing them into the open way of doing development so that it makes it very easy for other organizations to get involved. And then this crazy thing happened this year. So we were in the process of raising our sort of second round of funding. We were trying to figure out what VCs we're going to talk to, and we had all our slide decks that said, we want to be the Red Hat of storage. And then Red Hat came along and said, we want to buy you. And it turned out to be sort of all along, my personal goals at least were to make Ceph this sort of transformative technology. And a really key piece of that was having it be open source, having an open technology that was going to make sort of that paradigm shift within the industry. And Red Hat is always one of the only companies or one of the few companies that are in the space that really understands that and also can afford to buy us. So it ended up being, we went from being the Red Hat of storage to the storage of Red Hat. So that's very exciting. That just happened about, I guess, a month ago now. And one of the sort of first results of that is that what happened with Calamari. So the InkTank strategy was always to become sort of an enterprise distribution of Ceph. So we wanted to focus on the people with all the money because they could actually help, we could build a business around that. And so we had this InkTank Ceph enterprise product that we were selling. So it consists of a specific version of Ceph that we tested and backported fixes to and sort of validated and stabilized and so forth. There was this Calamari component that we started building about a year ago. That's a management layer and a web GUI and all the stuff that makes it much easier to manage a Ceph cluster. So it's sort of pulling you off the command line into a web browser. We were going to do all these enterprise integrations, so you can get things like SNMP and Hyper-V and VMware that nobody who's sort of in the open source community cares about, but the enterprises care deeply about, and so they're willing to pony up money for. And then, of course, the support SLAs around it. So that was sort of the enterprise product in a box. But sort of the difficult decision we had to make as a startup was that Calamari management layer we made proprietary because we needed to have something that was sort of in the box that we were selling that was not just support. So we thought. But it turns out that REDHAT's model is a little bit different, and they've been very successful with that. It's a pure open source company. Everything that they sell is pure open. And so one of the very first things we did after getting bought is open source that layer. So that's been very exciting, especially for the developers who've been working on it for a long time, but also the community has been very excited about that as well. So that felt good. And then that sort of brings us to the future. So that's sort of how we got to where we are today. What's coming next? What are we working on right now, and what do we see? So I think one of the things that we need to deal with sort of this year, I guess, is governance. So how do we make sure that the project community for Ceph is really strengthened? Because again, the thesis of all of this is that we need to have a very strong open source community around the project and leverage the efforts of all the different businesses who are building storage products and businesses around Ceph to make Ceph as great as possible. And if Ceph is successful, then those businesses will be successful. So there are a couple things. We just have to sort of formally acknowledge and document how governance in projects works. That means sort of acknowledging what my role is, which has been sort of informal up until now. Recognizing all the project leads who are sort of building all the subcomponents of Ceph. We do most of the heavy lifting these days when I'm flying around doing things like this. Formalize some of the processes around CDS and make the community roadmap more transparent. So it's very easy for people who want to get involved, particularly organizations who don't necessarily understand how open source works, to sort of plug into that community and contribute and so forth. There's also the possibility of creating an external entity that manages a lot of those shared resources. So we built a pretty big test lab as InkTank, big for us at least. How do we have the shared resources do lots of things like testing and hardware validation and all the different distros and platforms and so forth, and share those resources and make it very easy for people to plug into that. So these are sort of still things that we're exploring today. There's also, of course, the technical roadmap. What are we going to build next? And there are a couple sort of important questions we have to answer, right? So how do we reach all the new use cases? So how do we make Ceph and broaden the reach of Ceph? How do we make sure that the current people who have already sort of bet their businesses and products on Ceph, make sure that they're successful so that we're actually, not going to lose their data, for example. And how do we make sure, I think the balance is how do we make sure that Ceph is sufficiently successful in sort of the businesses that we have penetrated so that it really works well enough for the people who are investing there for those people to thrive. So we can't go too broad and try to solve every problem. We have to make sure that we also have that focus. So we have breadth to expand the community, but also enough focus to win in those spaces where we are penetrating. So there's a bunch of stuff that we've been working on. One of the new things in Firefly is tiering. So sort of diving into some of the architectural stuff. Client-side caches are great, but they only buy you so much. At some level, you have to realize that there are lots of different types of storage out there. There's slow disk, fast disk, flash, non-volatile memories are starting to show up. So the question is, how do we separate the hot and cold data within your storage system into different tiers, and so that you can sort of leverage both types of technologies. And there are a couple different things we're looking at. So the first is cache pools, which is what we did in Firefly, where you sort of move all the hot data into a fast tier, and so that it's fast, and then push the cold stuff back down. And then there's sort of the secondary problem of how do you take the really cold stuff and sort of move it off to something that's really slow, whether it's erasure coded or really slow disks or tape or whatever it is. And how do you decide what's hot and cold in those sorts of systems? So these sorts of tiering architectures are common in a lot of enterprise systems, and sort of a necessary ingredient for a lot of times, but typically not found in open source solutions. So the cache pools are new in Firefly. So we built a lot of sort of infrastructural stuff around how to layer different pools in RADOS, and we have sort of an initial tiering solution. So the goal is to make sure those work really well, and then add additional types of solutions that can leverage that. The other thing new in Firefly is erasure coding support. So traditionally, Ceph has always done replication for redundancy. It's flexible, it's fast, it's relatively simple, although it's actually still pretty complicated to get right. But the problem is that for large clusters, it's very expensive. So if you have a petabyte of data, and you have to tell a customer that they go buy 3 petabytes of disk, that can be a difficult sell. And it turns out that you can trade the performance of recovery after a failure with storage efficiency. So if you can store less data, it's just going to cost more when you're trying to do repairs. So for example, if you do 3x replication and you lose a disk, you have to read that one disk's worth of data to recover it in a replicated system. So you lose 1 terabyte, you have to read 1 terabyte to repair. In a erasure coded system, if you lose 1 terabyte, you have to read the entire stripe, so you end up reading like 5 terabytes or 10 terabytes in order to do that recovery. So it costs more when there's a failure to repair, but you only have to store, like 1.3, 1.5 times. And you end up with a much better overall data durability, assuming you can sustain that repair traffic. But it also turns out that there are these things called local recovery codes, which are sort of a midpoint. So you add a little bit of extra storage overhead, but then you can read less of the data when you recover. So if you only lose 1 disk, then you can read only a fifth or a third of the stripe, and if you lose 2 disks, then you have to read the whole thing. So we have erasure coding now in Firefly, and we're doing local recovery codes in the next release. So that's one of the things that developers are working right now. But there's some limitations and trade-offs. So erasure coded data is hard to modify because you have to rewrite the entire stripe of data across all your devices. But it's ideal for cold storage. So for lots of use cases, you can just use it out of the box. And for others, like block devices, then you have to sort of combine it with the cache tiering functionality that we also added in Firefly. But this is all new in Firefly, and I'm very excited. So the other big thing is figuring out how to do multi-data center. So there's sort of two things that are pushing us. So Ceph was originally designed, again, in the supercomputing context. We wanted to just have a data center full of disks, and you have a supercomputer shoveling data into it. So it's all synchronous replication, it's strongly consistent, all the things that make sense for low latency links. But there's growing demand for asynchronous replication and multi-data center stuff. So it comes from enterprises who need to have sort of a backup copy in another data center, for business reasons and for regulatory reasons. It also comes from sort of global web scale type companies that need to have highly available services that can tolerate entire data centers going down without loss of service. So there are a couple of different strategies that we follow to sort of satisfy this. So one is to look at all the different individual use cases, the different types of storage APIs that you build on top of Ceph, and solve them in sort of the specific ways that make sense for those APIs. So for example, for the S3 protocol RADOS gateway, we have one approach for solving it in that case, and then for the block device another way. And then the second strategy is to sort of build in, sort of at a very low level in the RADOS object storage layer, build in some multi-data center functionality. So we started with the sort of the per use case stuff. So initially, we've added multi-site, multi-cluster capabilities to the RADOS gateway. So the idea here is that you have this object storage service, and you create different regions, East Coast, West Coast, Singapore, Europe, whatever. And then you create all these different zones within those regions. And then you figure out how to federate this across lots of different Ceph clusters. So you federate the different zones together. And the goal here is to have sort of a global bucket and user namespace. So think S3, right? You have your S3 user, and you create different buckets. And that's the same across the entire service, but when you create a bucket, you create it on the East Coast or on the West Coast or whatever. So it's the same sort of data model that we provide. And the trick here is just to synchronize the objects across the zones in an asynchronous fashion. So you can do that. It's actually something that S3 doesn't do, actually, it turns out. So the RADOS gateway gives you the ability to have this sort of global namespace. But then it also lets you say that I want all the buckets that are stored on the East Coast to be replicated to another data center, maybe on the West Coast or somewhere else. And so if you lose an entire coast from an earthquake or flood or whatever, more likely it's an operator error. Then you can fail over to your backup copy. So this was added in the dumpling emperor timeframe, and we continue to support that and sort of extend the possibilities for dealing with that. On the block device side, we have a couple different ways you can sort of deal with multi-data center type solutions. So today we have this incremental backup functionality. So RBD lets you create snapshots on individual block devices and sort of efficiently keep track of those. And there's this incremental backup functionality where you can say, if you create 2 snapshots, you can take the difference between those 2 snapshots and efficiently ship that over the wire to another mirror image and then apply it. So this gives you very coarse-grained replication capability and disaster recovery. So you can do this on the granularity of hours or days. And so it's really sort of a backup solution, but that's good enough for some people. And then sort of looking forward, we want to have add the ability to do sort of a real-time replication for block devices. So not quite synchronous, but asynchronous. So you can have a replica that's trailing by seconds, or maybe configurably, so you want it to be exactly an hour behind that block device for disaster recovery purposes. And there's the ability to sort of add some whiz-bang features, like the ability to rewind a block device, because you have this sort of timeline of all the different changes that have happened to it. So if you have an operator or somebody accidentally includes something, you can sort of rewind the device to a point in time and then pull your data out, roll it forward again. So this is sort of what we're looking at for the next couple of releases to add to the block device. But then sort of the alternative strategy is how do you have sort of the other possibility is to add this at the lowest levels of Ceph. So you have at the low-level object storage layer, have this generic ability to replicate across data centers and have all the other services sort of piggyback on top of that. And it turns out this is a really hard problem. Because the whole point of the object store is that you're this massively scalable, right? You're sharding your data across thousands of servers. But at the same time, in order to have this work with all the different workloads that you're putting on top, you need to have point-in-time consistency of that replica in another data center. So you're both distributing things, and then you also need sort of a coherent timeline, which is sort of impossible from a physics standpoint. So there are a couple of different challenges. So one is to infer partial ordering of events within the system. One is to maintain that sort of stable timeline coherent across the source cluster to the stream from, and then replicate that to another cluster, and then make sure that on the target cluster it's applied in a way that you only sort of apply writes after you know that you have everything that logically happened before it. So that the complex applications, whether they're block devices or file systems or databases or whatever they're sitting on top, have a coherent view of storage. You have read after writes consistency and ordering and all that stuff. So this is a challenging research problem, and we're sort of trying to work through all the technical issues to figure out how to make it happen. So we've been collaborating with student programs and universities and so forth to try to push this forward so that we can make sort of a real solution to this problem. The exciting thing is that I don't actually know that. I'm not as familiar, I guess, with the proprietary space, but I don't think many systems do this, if any systems do this. And certainly not in a massively scalable way. So if we can figure this out, it's going to be very exciting. So, and then of course there's CephFS, the file system. So the irony is that Ceph started with a distributed file system. That's where it all began, and that's like sort of the one piece of the system that we don't sort of support and label production quality, which is very frustrating. So we want to change that. We want to finally have something that people can actually run in production. So today, most of the work is around improving the QA coverage and squashing bugs. The NFS and SIF support is now largely complete and robust, and we're continuing to improve the multi-metadata server performance and stability and so forth. But what's really still needed for CephFS is an ongoing QA investment. We just haven't had the resources as a small startup to really do all the testing, build all the testing, automation, and so forth to make sure that it works. So there's a lot of hardening that needs to happen, and then there's some of the features that are in Ceph aren't entirely complete or correct. So the snapshot stuff needs a lot of work. It's pretty cool to be able to create snapshots in any directory, but there's some issues that need to be cleaned up. The good news is that there's been an amazing community effort here. So even though InkTank hasn't been able to sort of afford the investment to do a lot of work here, a lot of what other organizations have. So we're going to hear from Cohort FS in the afternoon or morning, I guess, about their work with StuffFS. There's some engineers at Intel who are doing some amazing work on the kernel side and on the server side to make this work. So that's been very exciting. But I guess stepping back, again, we're seeing Ceph living in a much larger ecosystem, right? So we're interacting with sort of the Linux community and the kernel community to make sure that Ceph interoperates well with clients. Cloud obviously has been very big, so we're working with a lot of people in the OpenStack community, from Innovance and Marantis and REDHAT and so forth, to individual service providers. Even Cloud Stack integration is there. On the compute virtualization side, we're integrated with KVM and QEMU, and also Zen, to make sure that you can run hypervisors on top of block devices. There's the whole big data space with the Hadoop ecosystem and all the stuff that's sort of coming out of that, like Spark and so forth. And so you can plug Ceph as this file system storage layer underneath Hadoop and run all that stuff on top of Ceph, which is kind of exciting. There's all the sort of provisioning and DevOps stuff, all the chefs and crowbars and puppets and Ansibles and so forth in the world. So making sure that all the provisioning tools that people use for these large distributed systems will work well with Ceph. And then there's the legacy protocol support, right? So for NFS and CIFS and iSCSI support, making sure that Ceph can sort of work with those legacy protocols in those sort of legacy enterprise environments. Big data is sort of a big opportunity here. It's one that sort of frustrates me personally. Maybe because I'm not a big data person, I actually don't know a whole lot about it. But the thing that's always struck me is that the whole big data ecosystem is built around this HDFS and GFS type architecture that's just really a really stupid storage model. Like if you really come down to it, it's like big files and it's striping them, and it's really basic. Like we've got to be able to do better. Because at the end of the day, the real challenge is to move the computation to the data and to sort of manage the fact that the data is structured and has some move the computation there to actually deal with that in some of the data calls anyway. So RADOS, or Object Store, has this sort of really neat capability to inject code into the storage system. And we have sort of a rich data model for what you can put in an object. And then you can push code to the storage nodes to actually process it and return the results. So we have this sort of flexible compute storage hybrid that seems like it should be very exciting. It'll open up lots of possibilities, but so we're really trying to figure out how to engage that community and figure out how to build cool things on top of it. So I think that really amounts to sort of evangelizing the RADOS capabilities to make sure people are aware of what we can do, having sort of case studies and proof points and reference implementations and so forth, so that people can sort of plug into that set of APIs and ultimately, hopefully, build sort of this generic storage platform that's used in the enterprise and other organizations for all their other stuff, but also be able to leverage the sort of low-level capabilities of those systems to build cool stuff on top. The enterprise, of course, is sort of the big thing. It's really, these are the people with the money, so how do we, as a community and as a developer, it's really about how do we target those people that can pay us so we can get all our toys. So I think ultimately succeeding in the enterprise is going to come down to a couple different things. It means figuring out how to support the legacy and transitional interfaces. So sort of in the old world, there are all these client-server protocols where the client thinks it's talking to a single server. Obviously, with a scale-out architecture, that's not true. You're talking to lots of different servers. But all these old protocols are sort of stuck in the old world. And we need to support them before we can move people into the new world. So that's things like iSCSI and NFS and CIFS and legacy, proprietary hypervisors and stuff like that. So the overall strategy is really about identifying what the beachhead use cases are in order to get sort of Ceph in the door of these organizations. So for us, largely, that's been OpenStack, because all these people want to set up their private clouds. And once you sort of get in the organization, and they sort of see the economics of the architecture and those open source sort of solutions, then you can see that they can use that same infrastructure and platform for other use cases. So it's sort of a two-pronged strategy. You have sort of the bottom-up strategy of sort of earning the respect of the engineers and the ops people. So they're like, this is a solution that we should be using, and telling their managers that. And then there's, of course, the top-down solution where you have to have these big organizations like SUSE and Red Hat and whatever who have these sort of full solutions that they can go to trade shows and sort of tell the CIOs and so forth that this is what they can buy and the economics are better. So once you sort of have that two-pronged approach, then you win. So I'm sort of end on a aspirational note. So I think the real question for me is why do we think that these sort of uppity open source solutions are going to be successful? And I think it comes down to a couple of different things. First is that it's very hard to compete. As a proprietary vendor, it's very hard to compete with open source software. So it's an unbeatable value proposition, being able to have that flexibility on the hardware side and have sort of a very much lower cost burden on the software side. It's ultimately just a more efficient developer model when you're leveraging developers in so many different organizations collaborating on a single project. It's hard to compete with that with a pure proprietary product. The other thing is that it's very hard to manufacture a community. So you might have this fear of NetApp going and open sourcing ONTAP or something like that. And I think the reality is that that just can't happen because these organizations don't really understand how to build community and make that actually be successful. And also having sort of an existing legacy code base and throwing it over the wall has very rarely proved to be successful as if you look at sort of Ceph also has a very strong foundational architecture, so we spend a lot of time trying to make something that we think really is sort of the right way to do scale-out storage. So being able to build on that gives us sort of a leg up on a lot of the other alternatives. And I think one of the key things is that because we're open source on both the server side and the client side, we can sort of have the flexibility to innovate at the protocol level. So if you're a proprietary vendor and trying to sell a box, you have to speak NFS or iSCSI to all your clients because that's what the clients are running, which essentially is forcing you to support a legacy client server protocol with a scale-out architecture, which means that you have to do all this forwarding and proxying and annoying stuff on the back end. Whereas Ceph and other open source solutions can innovate on the client side so that the client understands it's talking to an entire cluster of servers and do it in a better way. So having a native Linux kernel client that supports ZFS and RBD is integrated in KVM and KEMU and so forth gives us a lot of advantages. And I think ultimately we're just part of an ongoing paradigm shift. So as projects like OpenStack have sort of demonstrated within the larger business community, people are realizing that these scale-out open source data center software platforms are better when they're open, right? You have all this collaboration, you have a lot of innovation happening in the space, and it's ultimately going to be cheaper and better and faster moving and cooler than buying the proprietary options. So that's it. Thanks everyone for coming.